What if the closest world to Earth that might harbour life was also one of the deadliest destinations in the universe? Just 4.2 light-years away, a small red star called Proxima Centauri burns with the power of billions of nuclear blasts every single second. Around it orbits a planet that has sparked endless curiosity, a rocky world that, at least on paper, could resemble home. Scientists call it Proxima b, and some even whisper about the possibility of alien life hiding there. But here's the catch. Between us and that potential second Earth lies a gulf so vast and so dangerous that even our boldest science fiction dreams begin to crumble when faced with reality. Crossing this space isn't just difficult, it's a challenge that laughs at the limits of physics, mocks the strength of our technology, and dares humanity to even imagine such a journey. Proxima Centauri feels deceptively close. Astronomers speak of it like a neighbour, the star next door, as if reaching it were only a matter of packing a suitcase and setting off down the cosmic street. But this friendly phrasing hides a truth that is nothing short of terrifying. Light itself, the fastest thing in existence, needs more than 4 years to travel the distance between us and Proxima. Imagine that. Photons that circle our planet 7 times in a single second still spend over 1,500 days racing across the void just to bridge the gap. For us, mere mortals strapped to rockets powered by chemistry and fire, the idea of making that trip becomes almost absurd. At our fastest recorded speeds, humanity would need tens of thousands of years to reach that system, longer than civilization itself has existed. And yet, this impossible gulf has become the stage for one of the greatest questions humanity has ever asked. Can we escape our cradle, reach another sun, and plant our flag among the stars? The dream of Proxima Centauri is not just about science or exploration. It is about survival, ambition, and the terrifying possibility that our future depends on a star that looks so close, but may as well be in another universe. Proxima Centauri feels like a neighbour. Scientists talk about it as if it were the house next door, a small step across the street of the cosmos. When you hear that it sits just 4.2 light-years away, the phrasing almost feels comforting, like you could hop in a car, turn on the radio, and be there by the time the next season rolls around. But the truth hidden beneath this friendly language is far more sinister. 4.2 light-years is close only when compared to the unfathomable distances between most stars. In reality, it is so far away that even light itself, the speed limit of the universe, needs more than 4 years to cross the chasm. To put that in perspective, a single photon leaves Proxima Centauri and races through the void at 670 million miles per hour, fast enough to circle Earth 7 times in just 1 second, and still requires more than 1,500 days of unbroken travel before it finally brushes against our planet. Light is relentless, unstoppable, and faster than anything we can even imagine. And yet the star that astronomers call our neighbour forces it into a marathon that defies human comprehension. Think about it differently. If Earth were the size of a marble placed in New York City, Proxima Centauri would be another marble dropped somewhere in the middle of the Pacific Ocean. Between those 2 points would lie no air, no land, no convenient rest stops or islands to break up the monotony. Just pure, absolute emptiness. A black void stretching without mercy. And hidden in that void are hazards that make the ocean analogy far too kind. Dust grains the size of microscopic sand specks drift invisibly through space, but at the speeds required for interstellar travel, each one becomes an armor-piercing bullet, carrying the kinetic punch of a hand grenade. Imagine trying to walk to the middle of the Pacific Ocean across water that occasionally hurls invisible bullets at you with the force of an explosion. That is what lies between us and Proxima. Even the numbers alone are crushing. 4.2 light-years equals roughly 25 trillion miles. If you wrote that number out, it would be a 1 followed by 13 zeros. A figure so enormous that the human brain struggles to hold it in focus. Count out 1 number per second without stopping to eat, sleep, or breathe, and you would spend nearly 800,000 years before you finished. Try imagining walking it. At an average human pace of 3 miles per hour, the trek would require 9 trillion hours of continuous movement. That equals over 1 billion years of non-stop hiking, longer than complex life has even existed on Earth. Dinosaurs would have risen, ruled, and died twice over in the time it would take you to make the walk. Even driving collapses into absurdity. A car racing down the highway at 70 miles per hour would need 350 million years to arrive. That is long enough for the continents to drift into entirely new configurations, for mountains to rise and erode into dust, and for humanity to vanish from history while something else entirely evolves to inherit the Earth. Air travel doesn't help much either. The Concorde, the fastest commercial airliner humanity ever built, could scream across the sky at more than 600 miles per hour. At that speed, the trip to Proxima Centauri would last nearly 5 million years. That is more than 15 times longer than our species has existed. If the very first Homo sapiens had boarded a Concorde on the day our kind appeared on Earth, the plane would still be less than halfway there today. Even the space shuttle, a machine capable of escaping our planet's gravity and circling the globe every 90 minutes, would need more than 1 million years to close the gap. These comparisons are not exaggerations. They are the only way to shrink incomprehensible distances into something we can even begin to grasp. And yet, we still underestimate just how terrifying that distance truly is. The gap between Earth and Proxima is so vast that you could line up 1 million solar systems side by side within it, and not a single star would come close to touching another. It is emptiness on a scale that mocks human imagination. Even when we send our fastest probes into the void, the reality becomes unavoidable. New Horizons, the spacecraft that thrilled the world by reaching Pluto in just 9 years, would need 78,000 years to make it to Proxima. That is not just a long road trip. It is the entire span of recorded human history, multiplied dozens of times. Civilizations would rise and crumble. Languages would evolve and die. And the descendants of those who launched the mission would be unrecognizable by the time the probe approached its target. Voyager 1, which has already crossed into interstellar space, will not arrive for 73,000 years. The Parker Solar Probe, which broke every speed record by slingshotting around our Sun at more than 400,000 miles per hour, would still need over 6,000 years to get there. 6 millennia of waiting, hoping and surviving before reaching a star that astronomers casually call nearby. This is the illusion of closeness, the cruel trick of cosmic scales. Our nearest neighbour feels like it should be within reach, as if a few technological leaps would bring it into the realm of possibility. But every comparison shows us otherwise. Imagine embarking on a road trip where the destination is so distant that your grandchildren's grandchildren would still be driving when the car finally rolled to a stop. Imagine sending a message that cannot arrive until 4 years have already passed, making every conversation feel like a time capsule. Proxima Centauri may sit in the night sky like a faint red ember, visible with the right instruments, but it might as well be an entirely different universe. And yet, we can't stop staring at it. We can't stop dreaming about it. The very fact that it is the closest makes it irresistible. It taunts us by being near enough to imagine but far enough to laugh at our weakness. It whispers of new worlds and possible life, but only if we dare to challenge the abyss between. This tension, between what feels close and what is actually impossible, forms the foundation of humanity's obsession with Proxima Centauri. Because if we can't even reach the star next door, what hope do we have of ever becoming a species that spans the galaxy? The illusion of closeness is not just a scientific curiosity, it is a mirror reflecting back the fragile limits of our technology, our ambition, and even our imagination. And confronting that illusion is the first step in understanding why the journey to Proxima is perhaps the most daunting challenge we have ever faced. When people hear that Proxima Centauri is 4.2 light-years away, the number doesn't land with the crushing weight it deserves. It sounds big, sure, but numbers in astronomy are always big. We are used to hearing about galaxies billions of light-years distant or black holes that dwarf entire solar systems, so 4.2 feels almost friendly, like the universe is tossing us a bone. But numbers without context are slippery. They don't grip the imagination until you start dragging them into the realm of human experience, into miles, hours and lifetimes that we can actually picture. That's when the scale stops being abstract and starts to become terrifying. Imagine for a moment that you decided to walk there. No spaceships, no advanced propulsion, just your legs carrying you across the void. If you kept up a steady 3 miles per hour, without sleep, food, or rest, the trip would take over 1 billion years. 1 billion years is so vast that the Earth itself was unrecognizable that long ago. Continents were still forming. Life on the surface barely existed. Dinosaurs were not even a possibility, let alone humans. By the time your endless walk ended, the surface of Earth would be a stranger to you. Its continents rearranged, its life forms evolved into creatures we couldn't even imagine. Humanity, if it somehow survived, would be as different from us as we are from the first bacteria. That is what walking to Proxima Centauri would mean. Driving is hardly better. Take a modern car cruising at 70 miles per hour. With the windows rolled down and the music blasting, you would still be stuck on the cosmic highway for 350 million years before you arrived. For context, 350 million years ago, the very first trees had only just begun to cover the Earth, and amphibians were crawling onto land for the first time. Civilizations have risen and fallen thousands of times in the tiny fraction of time that we call history. But to drive to Proxima, you would have to wait longer than the age of forests themselves. Imagine fueling that car for every mile, generation after generation, with no roads, no gas stations, just the endless, freezing black stretching in every direction. The absurdity is the point. Let's step it up. Forget cars. You decide to fly. The Concorde, the pinnacle of commercial air travel, could cruise at 600 miles per hour, faster than the speed of sound. A Concorde leaving Earth would still take 5 million years to reach Proxima. 5 million years ago, early humans were just beginning to stand upright, discovering fire and tools. Imagine boarding a plane as one of the first humans, a fragile creature figuring out how to survive on the savannah, and stepping off only after millions of years had reshaped the Earth into a completely different world. That is the kind of stretch we're talking about. Even spaceflight doesn't save us. The space shuttle orbited Earth at 17,000 miles per hour, fast enough to cross the Atlantic in less than half an hour. At that blistering speed, it would still need more than 150,000 years to make the trip. 150,000 years ago, our ancestors were carving tools out of stone, their brains and bodies not yet what we would recognize as modern human. Civilizations would not exist for another 140,000 years. To send the shuttle toward Proxima would be to commit to a journey longer than all of recorded human history, a voyage that would outlast every empire, every language, and every story we have ever told. The truth becomes starker when you look at the very fastest machines humanity has ever built. Voyager 1, launched in 1977, has been racing away from Earth for nearly half a century. It is moving at 38,000 miles per hour, faster than any commercial aircraft ever built, and it has already left our solar system, a breathtaking achievement. But even Voyager 1, at its relentless pace, will not reach Proxima Centauri for 73,000 years. 73,000 years ago, Earth was in the grip of an ice age. Neanderthals walked Europe. The first cave paintings were still tens of thousands of years in the future. That is how long it will take the most famous probe in history to cover the distance. New Horizons, the spacecraft that gave us our first close look at Pluto, is faster still. Launched in 2006, it made the trip to Pluto in just 9 years, a feat of navigation and engineering that stunned the world. But to reach Proxima Centauri, New Horizons would still need 78,000 years. Imagine humanity trying to keep the lights on, civilization running, and records intact across nearly 80 millennia of uncertainty. The very concept of mission control would be meaningless by the time the craft arrived. Languages would change, nations would fall, even entire religions could rise and vanish before a single human eye saw the data return. Even the Parker Solar Probe, the speed champion of human engineering, fails us. Designed to skim dangerously close to the Sun, Parker reaches speeds of over 400,000 miles per hour, faster than any object humans have ever created. At that speed, you might think the problem is solved. But even Parker would need more than 6,000 years to make the trip to Proxima Centauri. 6,000 years ago, humans were still in the Bronze Age, building the earliest cities in Mesopotamia and carving the very first written words into clay tablets. To send Parker to Proxima would be to launch it before the pyramids were built, only to see it arrive now. That is the gulf of time we're dealing with. And this is where the real trap lies. Every time humanity takes a step forward in speed, the gap doesn't shrink into something manageable. It simply shrinks into a smaller impossibility. What good is cutting the trip from 78,000 years to 6,000 when both timelines stretch longer than the span of all civilization? These speeds are marvels, yes, but they are marvels that highlight just how powerless we are in the face of cosmic scale. We are bound by rockets that sip at the ocean of energy compared to what is needed. Chemical propulsion, the same basic technology that launched Apollo to the moon, is hopeless against distances like these. It is like trying to row across the Atlantic Ocean with a spoon. You may be moving, technically, but the ocean doesn't care. The scale is merciless. And here lies the cruel irony. In every sense that matters to human beings, Proxima Centauri is both impossibly close and completely out of reach. It is the closest star to us, the one system that feels almost touchable, and yet it mocks every speed record we've ever set. It dangles like a carrot, whispering of alien worlds and second homes, while simultaneously slamming the door in our face with numbers that make a mockery of our progress. That is why scientists are obsessed with it, why dreamers can't stop staring at the faint red light in their telescopes. Because if we can't solve this speed problem, if we can't figure out how to bend the rules of propulsion and energy, then the nearest star will forever remain a mirage, a place that feels close enough to imagine, but far enough that we may never, in our entire existence, touch it. Every time humanity looks up at the stars and imagines a ship making the journey, the first instinct is to think bigger rockets, stronger engines, more fuel. It feels intuitive. If a small rocket can carry a satellite into orbit, then surely a much larger one could carry us to another star. But this instinct is where the real nightmare begins. Because buried inside the very mathematics of rocketry is a cruel law that crushes our dreams before they can even take flight. It is called the rocket equation, and it dictates with merciless precision why chemical rockets will never ever carry us to Proxima Centauri. The rocket equation is simple in theory, but devastating in practice. To accelerate a spacecraft, you need to throw mass in the opposite direction, burning fuel, pushing exhaust out the back, propelling yourself forward. The faster you want to go, the more fuel you need to burn. But here's the paradox. Every pound of fuel you add makes the ship heavier, which means you need even more fuel to accelerate that extra weight. So you add more fuel, which makes the ship even heavier, which demands still more fuel. It's a spiral with no escape, a mathematical black hole of diminishing returns. At some point, the rocket is no longer a ship. It is just a mountain of fuel sitting on the launch pad, waiting to explode under its own absurdity. Even our most ambitious rockets today illustrate this trap. The Saturn V, the towering monster that carried astronauts to the moon, stood 36 stories tall and weighed over 6 million pounds. But only a tiny fraction of that weight, just a few percent, was the actual payload, the part that went to the moon. The rest was fuel and the engines to burn it. Most of the rocket was sacrificed just to get a sliver of humanity into space, and that was for a trip of just 250,000 miles. Scale that to 25 trillion miles, and the numbers break so violently that they stop being numbers at all and start to resemble comedy. If you tried to build a chemical rocket capable of reaching Proxima Centauri at even a modest percentage of light speed, the mass of fuel required would dwarf entire planets. You could strip mine Earth for propellant, and it still wouldn't be enough. The equation simply laughs in your face. The problem gets worse when you think about deceleration. It's not enough to reach Proxima Centauri. You also have to stop once you get there. Otherwise, your starship simply screams past the system and vanishes into the black forever. To slow down, you need just as much energy as you did to speed up. Which means all that insane fuel mass has to be doubled. Imagine building a rocket so large it carries oceans of fuel to accelerate, and then carrying even more oceans of fuel just so you can hit the brakes 4 light years later. The absurdity stacks on itself until the numbers reach scales bigger than the mass of our sun. At that point, you're not launching a rocket. You're trying to launch a star. This is why every proposal for interstellar travel abandons chemical rockets almost immediately. They simply can't escape the tyranny of the rocket equation. The specific impulse, or efficiency, of burning fuel is just too low. The best chemical propellants barely squeeze a few kilometers per second out of their reactions, but Proxima demands speeds of tens of thousands of kilometers per second. The gap is so enormous, it might as well be infinite. It's like trying to cross the Atlantic Ocean with a child's squirt gun. The principle is there. You are technically moving water backward to go forward. but the scale is so mismatched that the attempt is hopeless before it even starts. And this isn't just a technical hurdle. It is a fundamental wall built into the very physics of rocketry. The rocket equation does not care how clever your engineers are, how ambitious your designs may be, or how large your budget is. It enforces its tyranny without exception. It means that for interstellar travel, every traditional rocket design is doomed before the first sketch hits the paper. This is why so many visionary scientists, when pressed about interstellar dreams, sound less like engineers and more like magicians. They start talking about antimatter, about bending space-time, about sails pushed by giant lasers. Not because they want to be fanciful, but because the alternative, clinging to chemical rockets, is simply impossible. Think about it this way. Every major leap in human exploration has come with new propulsion. The canoe carried us across rivers, but it was useless on the open sea until sails arrived. Sails gave way to steam, and steam to combustion engines. At each step, the new mode of power didn't just make things easier, it made new worlds accessible that were previously impossible. That's the situation we face with the stars. Rockets are our canoes, fine for hopping between islands in the cosmic ocean, useful for reaching the moon, Mars, maybe even the outer planets. But to cross to the next star, we need something entirely different. Something that breaks the cycle of carrying fuel to push fuel in a death spiral of inefficiency. This is why Proxima Centauri, despite being close, still sits like a ghost at the edge of our imagination. It forces us to confront the fact that our technology, as powerful as it feels, is nothing more than the first stumbling steps of a species still learning to crawl. We have tasted orbit. We have touched the moon. We have sent probes skating to the edges of our solar system. But the rocket equation sits above all of it. A reminder that until we master propulsion beyond fire and fuel, the stars remain a locked door. And the cruelest part is that the lock is not hidden. We can see exactly how it works, written out in mathematics so clear that any high school physics student can calculate why we are trapped. The key to the stars is out there, but it will never be carved from chemical propellants. And so the dream of Proxima is caught in a paradox. It is close enough to ignite our hunger, yet far enough to mock every attempt to reach it with the tools we know. The rocket equation makes sure of that. Every time you look at the star glowing faintly in the night sky, you are staring at the mathematical wall that separates humanity from becoming truly interstellar. And until we find a way to smash through that wall, or slip around it with something radical, the journey to Proxima Centauri will remain nothing more than a haunting mirage. A destination that whispers of possibility but cages us in the cruel logic of fuel, mass, and impossibility. When people hear that a trip to Proxima Centauri is just 4.2 light-years away, it is easy to imagine that the problem is only distance, that with enough patience and steady acceleration, we could eventually get there. But the truth is darker. Distance is not the only enemy, it is energy. The amount of energy required to push even the smallest object to a meaningful fraction of light speed is so staggeringly high that it dwarfs the output of all human civilization. The numbers are not just large, they are incomprehensible, orders of magnitude beyond anything we can currently harness. It is here, in the raw math of kinetic energy, that the dream of interstellar travel begins to feel less like an engineering challenge and more like an encounter with the impossible. Let's start small. Suppose we wanted to send a spacecraft weighing just 1 metric ton, a single car's worth of mass, to Proxima Centauri at 10% the speed of light. 10% might not sound like much, but it's already 30,000 kilometers per second, fast enough to circle the Earth in less than a second. At that speed, the 1-ton probe would carry kinetic energy equal to the total energy produced by the entire world for several months. Not days, not weeks. Months of every coal plant burning, every nuclear reactor humming, every wind turbine spinning, every solar panel collecting, all added together, all dedicated to accelerating just 1 ton to 1/10 of light speed. And that's before accounting for the fuel inefficiencies, losses, and the fact that decelerating at the other end would double the demand. Now imagine scaling that up. A realistic interstellar craft, something that could carry people, ecosystems, and the shielding needed to survive cosmic radiation, wouldn't weigh a ton. It would weigh thousands, maybe tens of thousands. Suddenly the energy requirement balloons into figures so large they don't even feel real. Accelerating a 100,000-ton starship, the size of a modest ocean liner, to just 10% of light speed would require energy on the scale of what the entire world produces in thousands of years. We would have to pour every watt of civilization uninterrupted into that single launch. Even then, the power demand would exceed our infrastructure by factors so large they almost mock the attempt. And that's at 10%. What if we aimed for something truly ambitious, say 50% the speed of light? At that point, the kinetic energy doesn't just increase, it explodes, because energy rises with the square of velocity. Doubling the speed doesn't double the energy required, it quadruples it. At half the speed of light, a 1-ton craft would carry as much energy as every nuclear weapon ever built, detonated all at once. A larger ship at those speeds becomes equivalent to harnessing the full output of stars. To call it unimaginable is almost too gentle. It's as if the universe itself placed a price tag on interstellar travel, and the currency is energy at scales only quasars and black holes casually throw around. This is where the conversation about propulsion shifts into surreal territory. People begin to talk about harnessing antimatter, the most energetic substance imaginable, where matter and antimatter annihilate into pure energy. 1 kilogram of antimatter reacting with matter would unleash as much energy as the largest nuclear bombs ever detonated. But even that, miraculous as it sounds, is a drop in the bucket compared to what would be required to push a starship across interstellar distances. And antimatter isn't just exotic, it is almost non-existent in nature and extraordinarily difficult to produce. All the antimatter humanity has ever created, across decades of experiments, wouldn't even power a light bulb for a few minutes. Yet to fuel an interstellar journey, we would need metric tons of the stuff, manufactured, stored, and safely controlled without a single mistake. The gap between the dream and the reality is almost insulting. Fusion, the process that powers stars, is another contender. Harnessing fusion would unlock energy densities far beyond anything we currently possess. But even the most optimistic proposals admit that the scale required for interstellar travel would make entire power grids look like toys. A fusion rocket could, in theory, propel a ship to respectable fractions of light speed, but the reactors would need to burn continuously for years, demanding engineering so advanced that it feels closer to magic than technology. And still, the energy bill would be astronomical. We are talking about amounts of fuel mined, processed, and burned that rival planetary scales. Even if we solved propulsion, the logistics of generating, storing, and directing that much energy are mind-bending. Imagine trying to store the output of every power plant on Earth for centuries, and then unleashing it in a perfectly controlled stream to accelerate a ship. The energy would have to be delivered with flawless precision, because at relativistic speeds, even slight inefficiencies or losses would translate into catastrophic failures. This is not like fueling a car or even a rocket. It is like attempting to capture lightning in a bottle the size of a mountain and then using it to push yourself into the abyss of space. And here's the cruelest part. The universe doesn't care about our ambition. It demands the energy up front mercilessly without shortcuts. The laws of physics don't offer discounts for good intentions or creative designs. To move mass at those speeds requires a certain amount of energy, and that amount is so staggeringly huge that it exposes just how small we are. The energy requirements make us realize that we are not a galactic civilization, not even close. We are a species still struggling to power our cities without choking our planet, dreaming about traveling to another star while barely able to keep the lights on sustainably here on Earth. And yet, the dream persists, because buried inside these impossible numbers is also a strange hope. The sheer scale of the challenge forces us to imagine technologies we do not yet possess, energy sources we cannot yet touch. Maybe we will one day crack fusion. Maybe antimatter will no longer be fantasy. Maybe we will find a way to harness the power of stars directly, or build Dyson swarms that collect entire suns' worth of energy. In that distant future, the price tag of interstellar travel might finally be affordable. But until then, every time we look at Proxima Centauri, we're staring not just at a distant star, but at an energy bill so enormous that it humbles our species into silence. And this is the great paradox of interstellar travel. It is not simply about distance or speed, though those alone are daunting. It is about energy, oceans of energy, rivers of power that dwarf our civilization. The dream is possible in the sense that physics does not forbid it, but possible is not the same as practical. The laws of nature have written the rules clearly. If humanity wants the stars, it must first learn to command the power of suns. Until then, Proxima Centauri will remain a taunting ember in the night sky, burning brightly, daring us to grow into a species worthy of the energy it demands. If the vast distances and crushing energy requirements weren't enough to humble humanity, space has yet another trick up its sleeve. A threat that doesn't come with a roar of engines or the explosive spectacle of fuel, but instead arrives silently, invisibly, and lethally. It is radiation, the hidden storm that fills the void between the stars. To the casual observer, space might look like nothingness, a calm black ocean stretching forever. But that apparent stillness is a lie. It is actually a battlefield flooded with high-energy particles, cosmic rays, and bursts of stellar fury that tear through flesh, metal and electronics alike. And for anyone daring to cross the void to Proxima Centauri, radiation is not a distant problem. It is the ever-present executioner, waiting patiently for the moment we underestimate it. On Earth, we are spoiled. Our planet has spent billions of years building us a fortress, an invisible shield that keeps radiation at bay. The thick atmosphere absorbs cosmic rays before they ever touch our skin, scattering them harmlessly. The magnetic field deflects charged particles, funneling them toward the poles where they create shimmering auroras instead of lethal storms. But the moment you leave this protective cradle, the universe reveals its true nature. Out there is no shield, no atmosphere, no mercy. Out there, every second is a slow bombardment of invisible bullets, each one a piece of high-energy matter moving at nearly the speed of light. These bullets are called cosmic rays. They come from everywhere. The sun, exploding stars, supermassive black holes tearing galaxies apart, and they don't care who or what you are. A single cosmic ray can rip through human DNA, shattering its structure, leaving behind damage that multiplies silently in cells until cancers bloom. Over days, months, and years, the cumulative effect is devastating. Astronauts on the International Space Station are already exposed to higher levels of radiation than we are on Earth, but their missions are measured in months, and even then the risks are significant. Now imagine a crew trapped inside a starship for decades or centuries, slowly marinating in radiation with no magnetic shield, no atmosphere, no escape. It wouldn't just be a health hazard, it would be a death sentence. And as if the background storm weren't enough, there are the sudden flares, the solar tantrums that can unleash deadly bursts of radiation in minutes. Our own sun is relatively stable, but even it occasionally hurls out coronal mass ejections, massive eruptions of plasma and charged particles that can fry satellites and black out power grids on Earth. For a ship in deep space, unshielded, caught in the path of one of these storms, the result would be immediate and catastrophic. Electronics would short out, systems would fail, and the crew would be cooked alive in an invisible oven of high-energy radiation. Now take that scenario and magnify it, because Proxima Centauri, the very star we dream of reaching, is a red dwarf, and red dwarfs are notorious for their violent tempers. Proxima Centauri is not a calm, steady sun like ours. It is a flaring monster. Astronomers have watched it brighten by factors of 10 or more in sudden outbursts, explosions of radiation that dwarf anything our sun produces. One such flare in 2019 was so powerful, it briefly made Proxima visible to the naked eye, something no one thought possible for such a dim star. For a planet orbiting close enough to be in the habitable zone, these flares are not inconveniences, they are sterilizing blasts. Imagine being bathed, not once but repeatedly, in radiation bursts strong enough to strip atmospheres and cook biospheres. For any ship approaching Proxima, this environment would be like sailing into a storm that never ends, where the lightning never stops and every strike is strong enough to melt your ship from the inside out. Shielding against radiation is not as simple as adding a few extra layers of metal. High-energy particles are so powerful they can punch through most materials. When they hit shielding, they often generate secondary showers of particles cascading radiation that can be even more dangerous. To truly protect a crew, you would need shielding several meters thick, often of water or other hydrogen-rich materials. But that creates another problem: weight. Every ton of shielding adds to the mass of the ship, which multiplies the already impossible energy requirements to accelerate. The more you try to protect your passengers, the more impossible the journey becomes. It is a vicious cycle. Add shielding, increase weight, demand more energy, which in turn demands more fuel, which in turn adds even more weight. The rocket equation laughs again, this time aided by the invisible hand of cosmic rays. Some dreamers have suggested that instead of building walls of shielding, we could surround ships with magnetic fields, artificial versions of Earth's protective bubble. In theory, magnetic shielding could deflect charged particles away from the hull, creating a safe zone for the crew. But building a magnetic field strong enough to protect a ship travelling at a fraction of light speed is no small task. The magnets would need to be immense, their energy demands gargantuan, their stability untested in the harshest of environments. It is an idea that may one day save us, but today it remains closer to fantasy than reality. And even if we solved it, the universe always has another card to play. Some radiation, the highest energy cosmic rays, cannot be deflected by any field we can imagine. They are so powerful, so fast, that they tear through magnetic fields like bullets through mist. The danger is not limited to the human body. Radiation also shreds technology. Sensitive electronics are particularly vulnerable. A single particle can flip a bit in a computer's memory, corrupting data, crashing systems, and triggering malfunctions that cascade into mission failure. A starship travelling to Proxima would need layers of redundancy, hardened electronics, and constant maintenance just to stay alive under the assault. But redundancy adds weight, hardened systems add bulk, and again the spiral continues. Every solution seems to drag another problem in its wake, as if the universe designed the journey not to be conquered but to mock our attempts. And yet, in this invisible storm lies one of the most terrifying truths of interstellar travel. Even if we somehow solved the distance, the speed, and the energy, radiation could still destroy us long before we ever arrived. It is the slow killer, the one that waits patiently, eroding health, eroding technology, eroding hope. It does not announce itself with drama or spectacle. It simply grinds you down until there is nothing left to save. For the dream of Proxima Centauri, radiation is not a footnote. It is the constant question mark hanging over every plan, every design, every hope. What makes it even crueler is that we already know what the endgame looks like. Without shielding, without protection, any crew attempting the journey would slowly succumb. Cells would mutate. Cancers would multiply. Nervous systems would degrade. Generations raised in such an environment would inherit damaged DNA, broken before they even had a chance to live. The ship would become less a vessel of exploration and more a floating tomb, drifting toward a star that would never be reached by living hands. And that, perhaps, is the greatest irony. The very cosmos we dream of touching is also the one that will kill us if we try. This is why radiation storms are the invisible killers of interstellar travel. They are the threats you cannot see, cannot feel until it is too late, threats that lurk in every cubic centimetre of the void. They are not as flashy as rockets or as dramatic as energy bills, but they are just as lethal, if not more so. Until humanity can tame this silent storm, every dream of reaching Proxima Centauri remains shadowed by the grim reality that the journey itself may destroy us long before we ever see its light. If the abyss between the stars was merely empty, humanity might dare to imagine surviving it. Distance can be measured, energy can be calculated, and even radiation, though terrifying, can at least be shielded against with enough ingenuity. But the void is not empty, and that truth is perhaps more unsettling than any number or equation. Scattered throughout interstellar space are specks of dust, grains of matter smaller than the head of a pin floating invisibly in the dark. Harmless on Earth, laughably insignificant in our daily lives, these grains transform into something monstrous when encountered at a fraction of light speed. At those velocities, interstellar dust is no longer dust. It is a weapon, a bullet, a bomb, each particle carrying the energy of destruction far beyond its size. And for any ship daring to travel to Proxima Centauri, dust might prove to be the most merciless killer of all. To understand why, consider the nature of motion itself. At ordinary human speeds, a speck of dust barely registers. If one drifts into your eye, you blink it away. If it lands on your desk, you wipe it off. But motion changes everything. Imagine that same speck travelling at 10% the speed of light, 30,000 kilometers per second. Its mass may be minuscule, but energy increases with the square of velocity. That means that even a microscopic grain of dust suddenly carries the kinetic punch of an artillery shell. Something smaller than a grain of sand becomes a projectile capable of blowing a hole straight through the hull of a starship. Now picture an entire ocean of such particles, invisible, scattered randomly across trillions of miles. Each one is a landmine waiting for the unlucky traveller, and here lies the cruelty. Interstellar space is filled with these particles. They are remnants of stars that lived and died before us, fragments of planets shattered in collisions, clouds of matter drifting since the birth of galaxies. To travel through them at relativistic speeds is to step into a shooting gallery where every bullet is invisible, every shot is silent, and every impact is fatal. It's not just the physical damage to the hull that matters. At those speeds, a single strike could vaporize into a plasma explosion, spraying fragments and radiation through the ship's interior, cooking crew and systems alike. One tiny speck, unnoticed until the moment of impact, could destroy an entire mission that took centuries to plan. Some engineers have suggested the idea of armor, thick plating to absorb the impacts. But this quickly runs into the same trap as radiation shielding: weight. To protect a ship moving at 10 or 20% of light speed, you would need walls of armor meters thick. Every ton of armor adds to the energy requirements, spiraling into impossibility. And worse, even thick armor doesn't solve the problem. At relativistic speeds, the impacts are so energetic that they behave less like collisions and more like explosions. Instead of a dent or a crack, you get catastrophic penetration, a chain reaction of vaporization, shockwaves, and structural failure. Armor doesn't stop explosions from happening, it just shifts the location of the blast. So perhaps deflection. Maybe instead of absorbing the bullets, you dodge them. One proposal imagines placing a giant shield hundreds of kilometers ahead of the main ship, a sacrificial barrier designed to intercept the dust before it reaches the vulnerable craft. The shield could be made of ice or another sacrificial material, constantly replenished as it erodes away under the barrage. But even this raises problems. How do you launch and maintain a shield that far ahead while traveling at a fraction of light speed? How do you keep it aligned, stable, and replenished across trillions of miles? The logistics are staggering, the energy demands crippling, and even then, all it takes is one particle, one miss, one failure of alignment, and the journey is over in an instant. Another idea turns to energy itself. Vaporize the dust before it can strike. Imagine the ship carrying massive lasers or particle beams, scanning ahead constantly, firing at anything in its path. In theory, this could reduce the dust to plasma before it impacts the hull. But the scale of this defense is beyond daunting. The ship would need to scan a corridor thousands of kilometers wide, constantly firing, constantly adjusting. The energy required to keep such a defense active for decades or centuries of travel is nearly as impossible as the journey itself. And even if you could vaporize the dust, the resulting plasma cloud would still slam into the ship at relativistic speeds, creating another set of problems. You can't escape the consequences. You can only shift them into new forms. The cruel reality is that interstellar dust is not a minor inconvenience. It is the invisible minefield of the galaxy, one that doesn't care about ambition or ingenuity. It does not announce itself with warning signs or predictable hazards. It simply waits, silent and deadly, for any ship foolish enough to move too fast. We already see hints of this danger within our own solar system. Spacecraft travelling even at modest speeds must contend with micrometeoroids, tiny fragments that punch holes in solar panels and chip away at delicate instruments. But those strikes happen at kilometers per second, not tens of thousands. Scale up the speed, and what is an inconvenience here becomes a catastrophe out there. And what makes dust even more terrifying is its invisibility. Unlike asteroids, which can be tracked, mapped, and avoided, dust is too small to see at great distances. There is no radar powerful enough to pick out every particle across trillions of miles. There is no way to chart a safe course through the void. A starship heading to Proxima would be in effect charging blind through a cosmic shooting gallery, gambling that the particles it encounters won't be the ones that end it. The longer the journey, the greater the odds that luck will run out. Some dreamers try to imagine exotic solutions, magnetic fields to deflect charged particles, clouds of gas released ahead of the ship to absorb the impacts, even ram scoops that collect interstellar hydrogen and use it both as fuel and as a shield. But every idea runs headlong into the same problem: scale. To protect a ship at relativistic speeds, the defenses must be perfect, constant and overwhelming. Space, however, is indifferent to perfection. It is too vast, too unpredictable, too merciless to allow anything less than flawless execution. And flawless is something no human technology has ever achieved. The grim truth is this: even if we solved propulsion, even if we mastered energy, even if we built ships capable of carrying us across the void, the dust between the stars would still wait for us, silent and deadly. It doesn't take a massive asteroid to destroy an interstellar voyage. It takes a single grain of matter, smaller than a speck of sand, striking at the wrong moment. The bullets are already loaded. The question is whether humanity will ever find a way to dodge them, or whether the dream of reaching Proxima Centauri will remain trapped behind this invisible wall of death, one that mocks us not with grandeur but with simplicity. This is the terror of interstellar dust, that the smallest things may be the deadliest, that the road to the stars is not blocked by walls or mountains, but by specks of matter drifting quietly in the dark. It is a reminder that the universe does not care about size, about effort, about ambition. It cares only about physics, and physics has armed the void with weapons too small to see, but too powerful to ignore. Until we find a way to survive those invisible bullets, the stars will remain a dream just out of reach, waiting beyond a minefield we cannot yet cross. If the distance, the energy, the radiation, and the dust weren't enough, there remains one more frontier just as deadly, though less obvious: the human mind. For as much as we talk about rockets, propulsion, and shielding, the real question of interstellar travel might not be whether our machines can survive, but whether we can. The abyss between stars is not only a physical gulf, it is a psychological one. To send human beings into that endless night is to challenge the most fragile and untested territory of all: our capacity to endure isolation, confinement, and the crushing realization of insignificance in a universe that never blinks. Life aboard an interstellar ship would not resemble the quick, heroic missions of Apollo or even the long months of the International Space Station. Those expeditions are measured in days or months, with Earth always hovering close, communications flowing almost in real time, and the comfort of knowing that home is just beneath your feet. But the voyage to Proxima Centauri would not be measured in months. It would be measured in decades, centuries, or more. The crew, if there is one, would know from the moment they left Earth that they would never return. Their journey would be one way, their lives dedicated entirely to a mission they would not live to see completed. And that knowledge alone, sitting heavy in the mind, might be enough to unravel sanity. Imagine it, waking every day to the same walls, the same faces, the same routines, knowing that no new landscapes or skies will ever appear outside the window. Beyond the hull is only blackness, unbroken, featureless, endless, for years, for decades, for generations. Human beings evolved under open skies, with seasons to mark the passage of time, with sunrises and sunsets to tether our circadian rhythms. Strip all of that away, lock us inside a metal box and force us to stare into the void forever, and the cracks will show. Claustrophobia, depression, anxiety, paranoia, all of them grow in such conditions like mold in damp corners. The void is not silent. It whispers in the mind, telling you that you're trapped, that you're small, that you're forgotten. We already see fragments of this in the isolation of long-term space missions. Astronauts aboard the International Space Station report psychological struggles even in low Earth orbit, where they can look down and see the Earth spinning beneath them, where they can talk to their families with only a second's delay, where missions last no more than a year. Even then, the monotony and confinement take their toll. Now stretch that reality across decades. Remove the view of Earth, replace the sight of continents and clouds with the eternal black, and add the knowledge that no one alive on Earth by the time you arrive will even remember your name. That is the abyss the human mind must stare into. Generational ships, often imagined as solutions, create their own nightmare. The idea is simple. If the journey takes too long for a single crew, you launch a self-sustaining society that reproduces aboard the ship, with children and grandchildren carrying the mission forward. On paper, it sounds practical. In reality, It asks something almost impossible. For human beings to live their entire lives inside a closed system, born not out of choice but out of necessity, their fate sealed before birth. Imagine being a child raised on a ship where every wall tells you that you are not free, that your entire existence is defined by a mission you never volunteered for. You will never feel rain. You will never climb a mountain or swim in an ocean. Your entire life is confined to steel corridors, recycled air, and the responsibility of keeping a mission alive for people you will never meet. That kind of generational burden may crush entire communities under its weight. Resentment, rebellion, despair, they are not just possible, they are inevitable. And then there is the silence. Communication with Earth, even at the speed of light, would take over 4 years one way. Every question, every cry for help, every update would vanish into a time delay so great it makes real conversation impossible. The crew would not just be isolated physically, they would be cut off from the rhythm of human life itself. By the time a message arrived, Earth might already be different. Governments could fall, languages could change, civilizations could collapse, and the crew would know none of it until years later. Eventually the link to Earth might feel less like communication and more like speaking to ghosts, voices from the past that no longer have relevance to the present. Imagine the psychological strain of living like that, suspended between worlds, belonging to neither. The human mind does not thrive in monotony, and monotony is what the stars demand. Day after day of maintenance, of rituals, of endless routine, with no breaks, no vacations, no variety. Every mistake would carry catastrophic consequences. Every argument magnified by the impossibility of escape. If tempers flare, there are no doors to slam, no walks to clear your head, no new scenery to reset your thoughts. You are trapped always, with the same few faces, the same few voices. The walls do not forgive, and the void outside is absolute. That kind of pressure can break even the strongest bonds, twist friendships into rivalries, and turn small conflicts into mutinies. History has shown us countless times that human communities fracture under stress, and there is no stress greater than the endless night between stars. Even if artificial intelligence and automation take much of the burden, the psychological challenge remains. Humans need purpose, meaning, stories to tell themselves about why they exist. On an interstellar ship, meaning becomes fragile. Why maintain systems day after day if you will never see the destination? Why raise children in captivity for a goal they did not choose? Why cling to survival when the universe outside mocks you with indifference? Without powerful myths, without stories stronger than despair, a crew may lose itself long before the ship ever arrives. Some argue that the solution lies in cryonics, in freezing the crew to sleep through the long night. But even that, if possible, creates its own horrors. Imagine going to sleep and waking to discover decades have passed, your friends dead, your ship changed, your mission still incomplete. Imagine repeating that cycle again and again until all sense of continuity and identity dissolves. Or worse, imagine being the one crew member chosen to stay awake while the others sleep, carrying the solitude of centuries alone, the only conscious mind aboard a drifting tomb. The abyss of space is not just physical, it is psychological. It forces us to confront the limits of human endurance not in strength or technology, but in spirit. Can we remain sane when cut off from Earth, from nature, from variety, from freedom? Can we keep purpose alive when generations are born and die without ever seeing the light of a sun that isn't their own? Can we live in a prison of our own making, locked not by walls but by the vastness of the cosmos? These questions may prove harder to answer than any problem of physics, because while we can design reactors and shields, no equation can guarantee the survival of the human soul under endless night. And so, even if we solve propulsion, even if we conquer energy, even if we survive radiation and dodge the dust, we may still be defeated by ourselves. The human mind, fragile, brilliant, desperate for meaning, may find the stars not as a new home but as a mirror, reflecting back our limits. The greatest abyss on the journey to Proxima Centauri may not be the space outside the ship, but the one inside every traveller's mind. Even if the human mind could endure the suffocating darkness of the interstellar void, another enemy waits silently within us, our biology. For all of humanity's achievements, from the first fire to the most complex machines orbiting above Earth, we remain fragile creatures of flesh, shaped by millions of years to survive only within the narrow cradle of our planet. We evolved to breathe its air, drink its water, feel its gravity, bask in the warmth of its sun. Remove any of these conditions, and the body begins to falter. In space, the decay of biology is relentless, slow but certain, eroding muscle, bone, reproduction, and health, until even the strongest crew becomes too weak to function. And on a generational ship bound for Proxima Centauri, this fragility magnifies into something even more haunting: the risk that across decades or centuries, biology itself may collapse. We already see the damage in astronauts who spend only months aboard the International Space Station. Without gravity pulling on the body, bones begin to dissolve, calcium leaches away, leaving skeletons brittle, prone to fractures. Muscles, unused for the simple act of standing or walking, waste away at alarming rates. The heart, no longer pumping against gravity, shrinks, weakening over time. Vision blurs as fluid shifts toward the head, pressuring the eyes. The immune system falters, wounds heal more slowly, and radiation exposure accelerates cellular aging. These are not small inconveniences. They are fundamental degradations of the human body visible after mere months. Now extend those months into years, then decades, then lifetimes aboard a ship where Earth's conditions are gone forever. What happens when generations are born and raised in an environment that erodes the body faster than it can adapt? Artificial gravity, often imagined as a solution, might help. But it is not so simple. Spinning sections of a ship to create centrifugal force could simulate gravity, but engineering such vast rotating habitats is not trivial. The structures would need to be enormous, stable, and resistant to decades of wear. If anything failed, if rotation faltered, generations of passengers could find their bodies collapsing within weeks. And even if such systems worked, gravity is only one piece of the puzzle. Space is saturated with radiation, and no artificial spin can block the invisible bombardment of cosmic rays. Each strike damages DNA, raising the risk of cancer, mutations, and genetic instability. Over one generation, the risks are significant. Over 10, 20, or 50 generations, the risks could snowball into catastrophic biological decline. The concept of generational ships asks something bold of biology: that we reproduce reliably, indefinitely, within the walls of a metal vessel hurtling through the void. But reproduction is not guaranteed, especially under the stresses of radiation and limited resources. What if fertility rates drop under long-term exposure? What if children are born with genetic defects that accumulate across generations? What if a single mutation, harmless in one person, spreads silently until entire lineages carry weakness that dooms them? Evolution on Earth unfolds with nature as its filter, selecting against harmful mutations. But on a starship, isolated, small in population, there is no such filter. Harmful genes might spread unchecked, reinforced through generations of limited diversity. The ship could become a closed loop of genetic decline, a slow-motion collapse written into the very DNA of its passengers. And diversity itself is a knife at the throat of the dream. To maintain a stable population over centuries, a generational ship would need careful genetic planning. Too few people, and inbreeding becomes inevitable, amplifying harmful traits. Too many, and resources collapse under the strain of feeding and sustaining them. The balance is razor-thin, requiring precision across lifetimes where even one famine, one disease, one unforeseen disaster could break the chain. And disease is not something that can be ignored. A ship that carries life inevitably carries microbes, bacteria, and viruses. On Earth, pathogens are balanced by ecosystems, immune systems, and vast populations. But in the closed ecosystem of a starship, a single mutation in a virus or bacterium could run unchecked, devastating a population with nowhere to hide. An outbreak in a confined society of a few thousand, or a few hundred, could be catastrophic, erasing generations of planning in weeks. Even without disease, nutrition itself becomes a ticking clock. Humans require complex diets, not just calories, but vitamins, minerals, and nutrients drawn from Earth's biodiversity. Reproducing that biodiversity in a starship is nearly impossible. Hydroponics and synthetic food can sustain calories, but what of the countless trace elements and compounds that our bodies evolved to depend on? Over decades, deficiencies may build up invisibly, weakening bones, crippling immune systems, impairing reproduction. Imagine generations raised on recycled air, recycled water, recycled food, each one slightly weaker than the last, until the society that reaches Proxima is a shadow of the one that left Earth. Psychological strain only compounds these issues. Stress itself is biological, altering hormones, suppressing immune function, increasing vulnerability to illness. On Earth, stress dissipates through variety, through new environments, new communities, the vastness of a living world. On a ship there is no variety, no escape, no relief. Stress would accumulate across generations like a poison, shaping children before they are even born, passed along in altered epigenetics. Entire lineages could be born into stress-induced weakness, their biology marked by the burdens of a mission they never chose. And what of adaptation? Some argue that humans could evolve to fit their new environment, but evolution requires time, thousands, millions of years, and populations large enough for natural selection to work. A starship's crew is too small, the timescales too short, the environment too artificial. Instead of evolution saving us, genetic drift and mutation may doom us. The biology of the final generation could be so degraded by radiation, inbreeding, and malnutrition that they are incapable of surviving even if they reach Proxima. Imagine the horror of arriving at a new world, a planet that could sustain life, only for the colonists themselves to collapse, too broken by centuries of decay to adapt. The tragedy would not be in the journey, but in its ending, a species that reached another star, only to find itself unfit to live there. Cryonics is often raised as a way around these problems. Freeze the crew, bypass biology entirely, wake them only when they arrive. But cryonics is untested, and biology resists being paused. Ice crystals tear cells apart, memory degrades, subtle structures collapse. Even if freezing were possible, waking carries its own risks. What if the process is imperfect, leaving minds scrambled, bodies damaged? What if generations wake to discover they cannot reproduce, or that centuries of suspension have altered them in unforeseen ways? The gamble is immense, and biology, once broken, cannot be easily repaired. The fragility of biology may be the cruelest irony of all. We dream of the stars as if they were waiting for us, as if reaching them were only a matter of building faster ships and stronger shields. But the truth is that the greatest barrier may not be outside of us. It may be inside, written into the fragile architecture of our cells. We are creatures of Earth, bound to its gravity, its air, its ecosystem. Strip us from that, and we unravel, slowly but relentlessly, across years and generations. And so, the dream of Proxima Centauri is haunted by this question, not just whether we can survive the journey, but whether we can remain ourselves at the end of it. Will the humans who leave Earth be the same as the ones who arrive? Or will they be so altered, so eroded by the slow decay of biology, that they are no longer truly us? This fragility may prove the most implacable barrier of all, because you can armour a ship against dust, shield it against radiation, and fuel it against the abyss. But how do you armour the human body against the slow betrayal of time, biology, and generations? That is the question the stars force us to ask. It is tempting to imagine that the hardest part of reaching Proxima Centauri is the journey itself, that if humanity could somehow conquer the distance, defeat the radiation, endure the dust, and preserve its biology, the prize waiting at the end would be worth it. A second Earth, a world ready to receive us, to cradle us, to let us begin again. That is the mirage that has animated countless stories, the seductive idea that beyond the void lies salvation. But Proxima b, the rocky planet orbiting in the star's habitable zone, is not the paradise the imagination paints. It is not a blue marble waiting for us to arrive. It is at best a hostile rock bathed in the temper of a violent red dwarf, and at worst, an uninhabitable wasteland incapable of sustaining life as we know it. The cruel truth is that colonization may prove not the beginning of humanity's expansion, but its end, because the dream of a second Earth is less reality than illusion. On paper, Proxima b sounds tantalizing. It sits in the so-called habitable zone, close enough to its dim star that liquid water might exist on its surface. It is rocky, like Earth, with a mass only slightly larger making it a plausible candidate for solid ground and a stable atmosphere. These facts are enough to ignite headlines, to fuel speculation about oceans, skies, and perhaps even alien life. But the numbers that tempt us are only surface deep, and beneath them lies an environment that would likely crush human colonists before they even stepped out of their ship. The first and most obvious problem is the star itself. Proxima Centauri is a red dwarf, smaller and cooler than our Sun, which means that its habitable zone lies extremely close to the star. Proxima b orbits its parent in just 11 days, hugging it so tightly that the planet is almost certainly tidally locked, one side in perpetual daylight, the other in endless night. The day side bakes scorched by constant radiation, while the night side freezes into permanent ice. The line between the two, the twilight band, might offer some semblance of moderation, but it would be a razor-thin strip where life could barely cling. Colonists would be forced to live forever in the borderlands of extremes, trapped between blistering heat and eternal cold, fighting to balance survival against an environment that allows no mistakes. Then there is the matter of radiation. Proxima Centauri is not a calm sun. It is a flaring monster, hurling bursts of deadly radiation into space with a violence far greater than our sun's temper. Astronomers have watched it flare so brightly that it momentarily outshone its normal glow tenfold. For a planet as close as Proxima b, these flares are devastating. They strip atmospheres, boil away oceans, and drench the surface in radiation storms lethal to life. If Proxima b ever had a protective atmosphere, it may already be gone, blasted into space by its star's fury. Colonists would not step out into fresh air. They would step into a barren world where the sky is poison, where every breath requires machinery, where every wall must be thick enough to shield against storms from a star that never rests. And even if an atmosphere somehow clings to the planet, it would not be one we could breathe. Earth's air is not a cosmic standard. It is a miracle, balanced by billions of years of biology. The right mix of oxygen, nitrogen, and trace gases is the product of life shaping its environment. On Proxima b, the composition would almost certainly be alien, unbreathable, perhaps toxic. Colonists would require domes, habitats, and sealed suits, not just to protect against radiation, but to breathe at all. Survival would not mean stepping into a welcoming world, but carrying Earth with them in tanks and machines, every breath dependent on technology that cannot fail. Water, too, is no guarantee. The habitable zone only suggests that liquid water is possible, not that it exists. Proxima b might be a desert, stripped dry by stellar winds, or a frozen wasteland locked in eternal night. Even if water exists, it might be locked beneath the surface, inaccessible without massive infrastructure. Colonists would have to mine, melt, and purify every drop, turning survival into a constant labour. There would be no rivers to drink from, no rain to replenish crops, no oceans to fish. Water, the substance that defines life, would be a treasure wrestled from a reluctant planet, not a gift freely given. And then comes agriculture. On Earth, plants thrive under the steady light of a stable sun. But Proxima Centauri's light is red, dim, and variable, flaring unpredictably. Photosynthesis, the process that sustains nearly all life on Earth, evolved to capture the spectrum of our sun's rays. Would Earth plants grow under the crimson glow of a red dwarf, battered by ultraviolet flares? Perhaps with genetic modification, with engineering, with controlled habitats, but never in open fields, never under an open sky. Colonists would grow their food in sealed environments, relying on artificial lights and recycled nutrients. Farming would no longer be a relationship with the land, but a mechanical process, fragile and finite, dependent on constant maintenance. A single failure could mean famine, and famine in space is not a slow decline, it is extinction. The psychological burden of such a colony cannot be ignored. Imagine stepping off a ship after centuries of travel, expecting a new Earth, only to find a hostile wasteland where every moment of survival requires technology, vigilance, and fear. The settlers would never walk barefoot in grass, never swim under a sunlit sky, never breathe without machines. They would not be pioneers stepping into a new frontier, they would be prisoners of a planet tethered to domes and life support, forever aware that one crack in the wall, One storm from the star, one failure of machinery would mean death. The dream of freedom among the stars would dissolve into the reality of confinement on an alien rock. Some optimists argue that Proxima b might harbour its own forms of life, perhaps microbial, perhaps stranger. But even if it does, the encounter would not be the joyous meeting of kindred spirits. Alien life could be toxic, incompatible with our biochemistry, dangerous in ways we cannot predict. Or worse, it could be so fragile that our presence alone, with our microbes and contamination, would destroy it. Colonization would become conquest, not communion, and the moral weight of such an act would shadow every step. The final irony of Proxima b is that even if it were habitable, even if it were a world where humans could survive, it would not be Earth. Earth is not simply a planet, it is home, shaped by billions of years of evolution, by skies we know, by rhythms we feel in our blood. Proxima b, no matter how carefully adapted, would never be the same. Colonists would always live as outsiders, strangers in a world that tolerates them but does not embrace them. They would look up at a red sky, not blue, at a dim star, not golden, and know that they are forever away from the place that gave them life. And so, the mirage of colonization shatters. The journey to Proxima Centauri is not a road to salvation, but to another cage, perhaps harsher than the one we tried to escape. It is not a second Earth, waiting patiently, but a reminder that Earth itself is unique, irreplaceable, fragile. The dream of colonization may inspire us, drive us to reach, to invent, to dream. But the reality is that the stars do not owe us a home. They are indifferent, merciless, and hostile. If humanity wishes to survive among them, it must build its own worlds, carry its own environments, and accept that no planet will ever truly be another Earth. Proxima b is not salvation. It is a mirage shimmering at the edge of possibility, a reminder that the hardest part of interstellar travel may not be the journey, or even survival. It may be facing the truth that when we arrive, there is nothing waiting for us but another hostile frontier. For centuries, whenever humanity has faced the prospect of catastrophe, whether through war, famine, plague, or environmental collapse, there has always been a whisper of escape. That whisper has grown louder with the rise of modern science fiction, which paints the stars as a backup plan, an escape hatch for a species that seems determined to push its own planet to the brink. If Earth fails us, the dream says, we can go elsewhere. And of all the elsewhere places, Proxima Centauri has become the brightest symbol. It is close, it might harbour a rocky planet, and it has become shorthand for the promise of a second chance. But this dream, seductive as it is an illusion. The truth, as merciless as the void itself, is that Earth is not simply one world among many. It is our only home, the only place that sustains us effortlessly, the only cradle from which we may never truly graduate. The idea that we can abandon it and start anew elsewhere is not salvation. It is fantasy. The illusion begins with distance. The stars seem so near when we look up, scattered like lanterns against the night, and the stories we tell ourselves make them feel attainable. But the gulf to Proxima Centauri is not a road trip, not a relocation, not even a migration. It is a chasm that swallows lifetimes, that mocks every ship we have ever built, that demands speeds and energies beyond the reach of our technology. Even the most optimistic scenarios imagine voyages lasting centuries or millennia. Colonization in that sense is not an escape, it is a surrender to exile, consigning generations of people to live and die in a metal coffin before ever glimpsing a new sky. If Earth were failing, would we call that salvation? Or would it simply be a slower death, drawn out across the void? But the deeper illusion lies in what waits on the other side. Proxima b, or any exoplanet we might one day find, is not Earth. Earth is not just a planet, it is a miracle. Its gravity is tuned perfectly to our bones, its atmosphere sculpted by eons of life to be breathable, its oceans balanced to recycle water, its ecosystems vast enough to feed us and heal us. Everything about our biology is entangled with this one world. To imagine we could simply walk onto another and thrive is to ignore the billions of years of evolution that shaped us here and nowhere else. Other planets may exist. They may even be rocky, may even orbit in the so-called habitable zone. But habitable does not mean welcoming. Habitable does not mean safe. and habitable certainly does not mean home. Even if Proxima b had air, it would not be our air. Even if it had oceans, they would not be our oceans. Colonization would mean living forever in domes, sealed habitats, machines that simulate what Earth gives freely. Every breath would be manufactured, every bite of food engineered, every drop of water rationed. Colonists would not be free. They would be tethered to life support systems that could never fail. Survival would not be a return to the natural balance, but a precarious fight against an environment that tolerates us only grudgingly, if at all. In that sense, escape is a lie. We would not be escaping to freedom but to captivity in another form, one where every second of life depends on machines that will eventually break. And even if we could build those machines, even if we could sustain them across generations, the truth is that Earth is already better than any alternative we could ever hope to find. Earth gives us what no ship, no dome, no alien rock ever could: abundance. The abundance of forests that grow without our tending, rivers that flow without our engineering, air that fills our lungs without tanks or filters. Here, we are free in a way we never would be anywhere else. To abandon Earth for Proxima would be like leaving a palace to spend eternity in a prison cell, and calling it liberation. It is only when we take Earth for granted that we fail to see how extraordinary it really is. The illusion of escape is dangerous because it encourages neglect. If we believe that salvation lies among the stars, then the temptation is to treat Earth as disposable, to think of it as a temporary shelter rather than an irreplaceable home. But the cold truth is that there is no alternative waiting for us. Not Proxima Centauri, not any exoplanet, not even Mars with its barren deserts and toxic soil. These places may one day host research bases, scientific outposts, even small colonies, but none of them can replace the Earth that made us. If Earth becomes uninhabitable, if we poison its air, boil its oceans, and burn its forests, then there is no backup plan. The stars will not save us. They will only reflect back the emptiness of our ambition, the futility of believing that the universe owes us a second chance. And yet the dream persists, because humans are creatures of story as much as flesh. The idea of escape comforts us, gives us hope when Earth feels fragile, when crises loom too large. It lets us imagine that even if we fail here, there will be somewhere else, some distant world to inherit our mistakes. But that comfort is a trap. It blinds us to the reality that Earth is not replaceable. It makes us believe that leaving is an option when in truth leaving is suicide by another name. We can explore the stars, yes. We can send probes, build stations, learn and expand. But escape? Escape is a mirage shimmering on the horizon, vanishing the closer we approach. Perhaps the true lesson of Proxima Centauri is not that we must go there, but that we must not squander what we already have. The star taunts us, close enough to inspire but far enough to humble. It reminds us that Earth is not a stepping stone, it is the foundation. We are bound to it not by limitation but by necessity. If we wish to survive, if we wish to thrive, it will not be by abandoning Earth, but by protecting it. The stars may beckon, but they do not forgive. The universe is vast, merciless, indifferent. Only here, on this fragile blue world, do we have a place that welcomes us without condition. The illusion of escape fades when you stare long enough into the truth. Earth is not disposable. Earth is not replaceable. It is the only home humanity has ever known, and likely the only one it ever will truly have. The dream of Proxima is powerful, inspiring, even necessary as a story to push us forward. But it is not salvation. The real salvation lies beneath our feet, in the soil, the water, the air we so often take for granted. The journey to the stars may one day define us, but it will never free us from the truth that without Earth, we are nothing. Proxima Centauri is a dream. Earth is reality. And reality, for all its flaws and fragility, is the only place we can ever truly belong. For all the impossibilities, for all the dangers, for all the crushing truths about distance, energy, radiation, dust, biology, and the unforgiving hostility of alien worlds, humanity still cannot let go of the dream of Proxima Centauri. We know the numbers mock us. We know the physics humiliate us. We know the journey is beyond our reach, and that even if we somehow arrived, the destination would not be a paradise, but a prison carved out of rock beneath a hostile star. And yet, night after night, We lift our eyes to the heavens and whisper, someday. This is the paradox at the heart of our species. The same dream that logic dismisses as fantasy continues to inspire art, science, exploration, and imagination. It is not practicality that keeps Proxima alive in our collective vision. It is something deeper, something bound to who we are. At its core, dreaming of Proxima is less about escape than about identity. Humanity has always defined itself by reaching beyond limits. The first stone tools were not practical in the long run. They were fragile, crude, often breaking in use, yet they carried us forward. The first canoes that set out across oceans were far from safe. Most surely failed, many never returned. But still, we sailed. The rockets that carried us into orbit, that touched the moon, were not efficient, nor sustainable, nor capable of taking us farther. But they proved it was possible. And that proof mattered more than practicality. Proxima is the latest horizon, the most distant shore. To dream of it is to declare that we are more than creatures of survival. We are creatures of curiosity. This paradox is what keeps scientists and visionaries awake at night. They know the rocket equation laughs at us. They know the energy demands are obscene. They know radiation storms and dust clouds are merciless. But they also know that every impossible challenge humanity has ever faced eventually gave way, not because the challenge grew smaller, but because our minds grew larger. Fire was once impossible. Flight was once impossible. Splitting the atom was once impossible. Reaching the moon was once impossible. And though Proxima sits on a pedestal higher than any before it, the very act of saying we cannot plants the seed of someday we will. That seed is the paradox. The impossibility is itself the inspiration. Proxima Centauri embodies this paradox perfectly because it is both close and unreachable. If it were 10,000 light-years away, no one would bother. If it were 10 million, the idea would never have taken root. But at 4.2, it is close enough to tempt, yet far enough to terrify. It is like a door we can see but cannot open, a neighbour we know exists but cannot visit. That tension drives the imagination because it feels like a challenge personally designed for humanity, the nearest star system, daring us to grow, to evolve, to transcend. It is not the practicality of colonization that fuels our obsession. It is the symbolism. To reach Proxima would mean we have finally escaped the boundaries of our birth. It would mean that humanity, fragile and flawed, has become interstellar. And so, we imagine. Writers spin tales of starships cutting across the void, of alien worlds teeming with life, of colonies thriving under red skies. Filmmakers show us visions of human persistence against impossible odds, stories where technology saves us, where courage wins the day. Children look up at the stars and wonder what it would feel like to stand on another planet, to breathe air beneath a sky not our own. These stories are not lies, they are aspirations. They are the fuel that drives engineers to sketch impossible designs, that drives physicists to ask questions of the universe, that drives civilizations to fund research that may not bear fruit for centuries. Proxima is not just a star. It is a canvas on which we project our hunger for more. The paradox deepens when we consider that most of those who dream of Proxima know they will never see it. No one alive today will stand on Proxima b. No one alive today will even see a ship launched in that direction. Yet the dream persists because it is not personal. It is generational. Humanity dreams not for itself, but for its descendants, for the echo of its existence. To reach Proxima is to declare that we were here, that we did not stop at Earth, that we dared to step into the cosmic ocean. It is a legacy, not a plan, a message carved not into stone but into light, saying, we were small, but we reached. The paradox is also practical in an indirect way. Though we cannot reach Proxima now, the act of trying changes us. Research into interstellar travel forces breakthroughs in propulsion, in energy, in materials, in medicine. The dream of the stars trickles down into technologies that save lives on Earth. The Apollo program did not colonize the moon, but it gave us advances in computers, communications and engineering that reshaped the modern world. So too does Proxima function as a catalyst. The dream itself creates innovation, even if the dream is never fulfilled. In that sense, the impossibility is not a failure but a forge. There is also a darker paradox. The very impossibility of Proxima makes it safe as a dream. Because it cannot be reached, it can never disappoint. We can project onto it our fantasies of a second Earth, of alien contact, of salvation, without ever facing the reality of dust, radiation, and barren rocks. In some ways, Proxima's greatest power is that it remains out of reach, always more perfect in imagination than it ever could be in reality. The dream is immortal precisely because it cannot be tested. We chase it not because we expect to catch it, but because chasing it gives us meaning. And maybe that is the truest paradox of all, that Proxima is both impossible and necessary. Impossible because physics, biology, and the merciless scales of the universe block every path we can conceive. Necessary because without such dreams, humanity risks stagnation, risks folding inward, risks forgetting that it was born to look up. Proxima is less a destination than a mirror, showing us the part of ourselves that refuses to stop reaching. The numbers say no, the universe says no, but our imagination says yes, and in that yes lies everything that makes us human. So we keep dreaming, we keep sketching designs, writing stories, watching the sky. We know Proxima is not salvation, not a second Earth, not even a realistic plan. But it is a challenge, and challenges are what define us. One day, perhaps thousands of years from now, some descendant of ours may finally crack the problem, may finally build the ship, may finally set foot on the twilight strip of Proxima b. Or maybe they won't. Maybe Proxima will remain forever beyond our reach. Either way, the paradox remains. The dream sustains us, even if the stars never will. At the end of it all, when the arguments have been made and the obstacles laid bare, Proxima Centauri remains where it always has been, burning quietly in the southern sky, only 4.2 light-years away, close enough to tantalize, far enough to humble. We may spend lifetimes arguing about propulsion, about biology, about colonization, about the futility of escape, but none of it changes the star itself. It will continue to flare, to burn, to circle its slow dance with Alpha Centauri, indifferent to our hopes and our fears. And perhaps that indifference is the greatest lesson Proxima has to offer. Because in chasing it, in imagining it, in measuring the abyss that separates us from it, humanity has learned something profound, not about the star, but about ourselves. The journey to Proxima, though it exists mostly in imagination, has forced us to confront the limits of our species. We are creatures who evolved to run across savannas, to breathe an atmosphere sculpted by forests, to drink from rivers carved by rain. Everything about us, from our cells to our psychology, is bound to the fragile biosphere of Earth. Proxima makes us face the truth that beyond this planet lies an environment so hostile it borders on impossible. Distance mocks us. Physics humbles us. Biology betrays us. The star reminds us that we are fragile, temporary, bound by forces older and stronger than ourselves. Yet it also reminds us of our stubbornness, our refusal to stop asking what if, even when the answer is no. That tension, the clash between fragility and defiance, defines what it means to be human. In a sense, Proxima is less a destination than a mirror. When we look toward it, we see not a second Earth but the outlines of our own ambition. We see how quickly we reach beyond what we can touch. We see how deeply we crave meaning beyond survival. We see how, even when the odds are infinite, the dream persists. And that dream has power. It fuels stories, science, exploration. It shapes the way we see ourselves as a species, not merely as inhabitants of Earth, but as wanderers in waiting, apprentices of the cosmos. Even if we never arrive, the very act of striving makes us more than what we were. The paradox of Proxima is that it is both impossible and essential. Impossible because no technology we possess, nor any on the near horizon, can make the journey feasible. Essential because the impossibility itself drives us forward. Every time we run against the walls of physics, we are forced to think bigger, to imagine harder, to innovate. Every time we measure the gap, we refine our understanding of energy, of time, of survival. And even if those innovations never carry us to Proxima, they ripple back into our lives on Earth, improving the world we already have. In that way, the star teaches us without ever needing to be reached. And perhaps that is the final irony. Proxima Centauri, the symbol of escape, may instead be the reason we stay. By showing us how impossible departure truly is, it forces us to cherish what we already possess. Earth, fragile and finite, is no longer something to take for granted when compared to the hostile rocks that orbit other suns. When we imagine a life under the dim light of a red dwarf, chained to domes and machines, we begin to see the miracle of open skies, of rain that falls freely, of air that does not need to be rationed. Proxima, by denying us a home, reminds us to care for the one we already have. The illusion of escape collapses, leaving in its place the urgency of stewardship. The stars do not exist to save us. They exist to remind us that only Earth can. Yet even with this sobering lesson, the dream does not die, nor should it, because while Proxima may never be our second Earth, it still represents something greater, the story of human aspiration. The act of dreaming of another star binds generations together, giving us a continuity that stretches beyond a single lifetime. We may not reach it, but we can imagine our descendants trying, and in imagining them, we find meaning for ourselves. Proxima is the symbol of a torch we pass forward, not because it will ever burn at its destination, but because passing it is who we are. Perhaps one day, thousands of years from now, some distant child of humanity, or perhaps some descendant we cannot yet imagine, part human, part machine, will finally bridge the gulf. They may look upon Proxima B's twilight strip, upon the line between its eternal day and eternal night, and they may build a life there, or they may only stop briefly, refuel, and continue outward. Either way, they will look back toward Earth, across 4.2 light years, and know that they came from a fragile world that dared to dream beyond its limits, and in that moment, it will not matter whether Proxima was paradise or prison. It will matter only that we had the courage to dream it at all. In the end, Proxima Centauri is not about colonization. It is not about escape. It is not even about survival. It is about identity. It forces us to ask who we are when faced with the impossible. Do we surrender, or do we imagine? Do we cling to comfort, or do we stretch beyond reason? The star is silent, but in its silence, it demands an answer. And our answer, time and again, has been to dream. To imagine ships that do not yet exist. To write stories of futures that may never come. To teach children to look up, not down. That answer is not practical, it is not efficient, but it is profoundly human. So when we speak of Proxima, we are not really speaking of a star. We are speaking of ourselves, of our fears and our hopes, our frailty and our defiance, our despair and our imagination. Proxima Centauri may never host a human colony, may never feel the touch of our feet, may never hear the sound of our voices, but it has already shaped us, already challenged us, already given us the gift of perspective. It has reminded us that we are fragile, that Earth is precious, that the universe is vast, and it has reminded us that we are dreamers, forever restless, forever reaching. The star that cannot save us may, in the end, be the star that defines us. Not because we reached it, but because we tried. Not because it offered us a home, but because it forced us to see our own. Not because it was attainable, but because it was not. That is the paradox and the power of Proxima Centauri. It is not just a neighbour in space, it is a teacher, silent but relentless, telling us who we are and who we might become. And long after we're gone, long after our cities crumble and our stories fade, Proxima will still be there, a red ember in the darkness, whispering the same question into the night. Will you reach for me? And even if the answer is no, the attempt itself will echo forever as proof that humanity was here, small, fragile, bound to Earth, yet daring to dream of the stars. When the story of humanity is told far in the future, whether by our descendants, by machines we build, or perhaps by no one at all, there will be certain ideas that stand out as more than just ambitions. They will be seen as defining myths, dreams so large that they shaped us even if they never came true. The dream of Proxima Centauri belongs to this category, because it is not simply about reaching another star. It is about proving to ourselves that we are capable of imagining the impossible, of daring to look into the abyss and refusing to bow to its silence. Proxima may remain forever beyond our grasp, but the legacy of dreaming about it will endure far longer than any single mission or technology. It is not the act of arriving that matters. It is the act of striving, of believing that our tiny species clinging to a fragile planet can reach beyond what seems allowed. That belief has power, and it is that belief more than any spacecraft that will echo through the ages. From the earliest days, humanity has always lived on stories of what cannot be done. The first sailors who pushed into the horizon had no proof that land lay beyond the waters. The first aviators who strapped themselves to fragile wings had no certainty they would rise. The first astronauts who rode rockets into the unknown knew the risks could kill them. Yet in each case, the impossible became reality, not because the universe made it easy, but because we refused to accept its boundaries. Proxima Centauri is the ultimate horizon, the most distant shore that still feels close enough to name, close enough to tempt, close enough to make us believe that, with enough ingenuity, we could get there. It is not just a star. It is a mirror of our species' hunger for more, and its legacy lies in how it has already pushed us to think differently about who we are and what we might become. This legacy is not built only in science and technology, though those fields have certainly been inspired by the dream. It lives in art, in literature, in the way children trace constellations and whisper about alien worlds. It lives in the way societies fund research into propulsion, not because it will solve tomorrow's problems, but because it speaks to something deeper in us. It lives in the way philosophers talk about destiny, about whether humanity is meant to remain bound to Earth or whether our fate is to scatter among the stars. These conversations, these inspirations, these restless longings are part of the inheritance of Proxima, even if no ship ever sails there. The star gives us meaning not because it is reachable, but because it dares us to imagine that we might one day reach. And yet the legacy is complicated. To dream of Proxima is also to confront our own fragility, our dependence on Earth, our vulnerability to forces far greater than ourselves. It reminds us that we are small, that we are temporary, that the cosmos is vast and indifferent, that confrontation is humbling, sometimes even despairing, but in that humility lies wisdom, for without Proxima, we might believe too easily that we are masters of the universe, that technology will always solve our problems, that we can always escape the consequences of our actions. Proxima says otherwise. It says the stars are not waiting to save us. It says the universe does not bend to our desires. It forces us to see Earth not as something to abandon, but as something to treasure. The legacy of Proxima, then, is not only the fire of ambition, but also the weight of responsibility. It is both dream and discipline. Consider what happens when a child looks up at the night sky and asks whether we could ever reach those stars. The answer is no, not now, not for centuries at least. But the question itself is enough. It sparks a curiosity that might lead that child to study physics, or to become an engineer, or to write stories that inspire others. That child might never build a starship, but they might build something else, something that changes the world in ways unforeseen. This is how the legacy spreads. The dream of Proxima does not need to be fulfilled to have meaning. It only needs to be imagined. Its power lies not in the arrival, but in the pursuit. There is also something timeless in the way the dream transcends generations. No single lifetime can hope to see Proxima reached. But the dream endures across centuries, whispered from one age to the next, evolving with each telling. That continuity itself is a kind of immortality, a thread that connects us through time. In dreaming of Proxima, we join with those who came before us and those who will come after, united not by success but by aspiration. Long after our cities have crumbled, long after our empires have fallen, the dream will remain, carved into the collective memory of a species that always looked upward. That is legacy, not the achievement itself, but the enduring hunger that outlives every obstacle. Even if we never leave Earth, Proxima Centauri has already fulfilled a role greater than being a destination. It has become a symbol of humanity's restless spirit, of the refusal to be confined by circumstance. That refusal matters more than the outcome, because in the end, the universe may never permit us to leave our cradle. Physics may remain unbending, biology may remain fragile, distances may remain infinite, but the fact that we still dream, still write, still imagine, is itself proof that we are more than animals surviving day to day. We are storytellers, visionaries, architects of futures we may never live to see. And in that role, Proxima has already succeeded. It has already given us meaning, already taught us to stretch beyond ourselves, already become a part of our identity as a species. The legacy of the impossible dream is this, that impossibility itself becomes fuel. that the more the universe denies us, the more we are inspired to resist, that by staring into the abyss and imagining what lies beyond, we define ourselves as creatures who refuse to stop at survival. Perhaps that is all Proxima was ever meant to be, not a second Earth, not a promised land, but a challenge, a riddle written in starlight, daring us to imagine the impossible. And whether or not we ever solve it, the act of trying will have shaped us forever. One day, perhaps, the dream may even outlast humanity itself. If we vanish, if our species falls to time or to catastrophe, Proxima will remain, burning quietly, untouched by our absence. And yet, the dream of reaching it may survive in the artifacts we leave behind, in books, in data, in the machines that outlive us. Maybe, in some distant future, another intelligence will stumble upon those records and see that we once dreamed of the stars. They will know us not for the empires we built or the wars we fought, but for the impossible horizon we refused to stop chasing. That too is legacy, to be remembered not for what we achieved, but for what we dared to imagine. So when we speak of Proxima Centauri, when we speak of the nearest star beyond our own, we are not really speaking of astronomy. We are speaking of humanity's greatest inheritance, the courage to dream against reason, to strive against limits, to hope against certainty. That inheritance is the fire that carried us from caves to cities, from oceans to skies, from Earth to the edge of space. And even if it never carries us further, it will remain the defining light of who we are. Proxima does not need to welcome us. It has already changed us. Its legacy is not in the reaching, but in the dreaming, and in that sense the impossible dream has already come true. There will always be another horizon. That is the truth that has followed humanity since the first time we lifted our eyes to the night sky and felt the pull of something beyond. Horizons have defined us, challenged us, shaped us, even when they seemed unreachable. The edge of the forest, the line of the mountains, the shimmer of the sea, the curve of the earth, the void above, all of them once felt like limits, and all of them became stepping stones. Proxima Centauri is only the latest in this endless chain of horizons, the most distant yet the most personal, the one that lingers just close enough to haunt us. And though it will almost certainly never be ours to claim, its power lies not in being conquered, but in reminding us that the horizon never ends. For every boundary we meet, there will always be another waiting, silent, indifferent, daring us to try. The endless horizon is not about arrival. It is about pursuit. Proxima Centauri is not unique in being out of reach. Every star is. Every galaxy, every cluster, every corner of the cosmos stretches away from us faster than we could ever follow. The universe itself expands, carrying its most distant parts beyond even the speed of light, making them forever untouchable. If we lived for 1 trillion years, if we mastered every form of propulsion, if we bent matter and energy to our will, still the universe would retreat faster than we could chase it. That is the reality written into the fabric of space-time. And yet, this endless retreat is not despair. It is meaning. Because meaning is not found in arrival, but in the chase. It is found in the refusal to let the horizon silence us. It is found in the decision, over and over again, to keep moving forward even when forward has no end. This is why Proxima Centauri matters. Not because it is the closest star, not because it might harbour a planet, not because it could ever be a second Earth. It matters because it is the horizon we can name. It matters because it is the boundary that speaks to us personally, whispering, "Here I am, just out of reach." It matters because it forces us to face who we are when confronted with the impossible. Do we surrender, or do we dream? Do we shrink into survival, or do we reach into the void? The answer, time and again, has been the same. We dream, we reach, we imagine. That is the endless horizon's gift. It never lets us stop. The epilogue to this story is not an ending. It is an opening. Proxima Centauri, whether we ever reach it or not, will continue to remind us that there is always something greater, always something further, always something beyond. It will continue to be the fire that pushes us to build, to learn, to tell stories that keep the flame alive. And in that way, the dream will never die, because it is not about the star itself. It is about us. It is about the refusal to believe that we are confined to what is given. It is about the audacity to say that even if the cosmos denies us, we will still dare to imagine. The endless horizon is not a place, it is a mindset, and there is something profoundly human in the knowledge that the horizon will always slip away from us. Because it means there will never be a final frontier, there will never be a last journey, a last discovery, a last dream. Every step we take, every boundary we cross, reveals another waiting in the distance. That is not futility, it is immortality of a kind. As long as there are horizons, there will be reasons to keep going. As long as there are stars like Proxima Centauri burning just beyond our reach, there will be stories to tell, questions to ask, hopes to kindle. We may never touch them, but in trying, we become more than what we were. Perhaps that is what the universe is for, not to be conquered, but to be chased. Perhaps its endlessness is not a cruelty but a gift, ensuring that we never run out of horizons to inspire us. Proxima Centauri may be the symbol of this truth, but it is not the only one. There will always be another Proxima, another unreachable shore, another impossible dream waiting to remind us of who we are. And in that reminder lies our legacy, our identity, our story. The endless horizon does not promise comfort. It does not promise survival. It does not promise that humanity will last forever, or that our dreams will outlive us. But it promises something greater than certainty. It promises that even in the face of impossibility, meaning endures. It promises that even if we fail, the act of striving is enough. It promises that as long as we keep dreaming, as long as we keep imagining ships that do not exist, worlds we cannot reach, and futures we will never see, we will remain what we are meant to be, restless, defiant, human. So when you look up at the night sky and see that faint red star hiding among the constellations, remember that it is not only a star, it is a horizon, a question, a challenge, a story. It is the symbol of everything we are and everything we might become. It is a reminder that the horizon never ends, that the chase never stops, that the dream never dies. And long after we are gone, long after our voices fade and our monuments crumble, the horizon will still be there, waiting for whoever comes next. That is the endless horizon's promise, that the story will continue, even without us, even beyond us. The epilogue, then, is not conclusion, but a torch handed from generation to generation, from dreamer to dreamer, from one fragile species to whoever inherits the cosmos after us. And in that torch lies everything we are, fragile yet ambitious, temporary yet eternal in our desire, small yet infinite in our imagination. Proxima Centauri is only one spark in that fire, one horizon in an endless chain. But it has taught us the most important lesson of all. That meaning is not found in what we reach, but in what we strive for, that the horizon never ends, and neither does the dream. Long before rockets or telescopes, long before the mathematics of relativity or the discoveries of distant worlds, humanity lived under the silence of the night sky. That silence has always been more than the absence of sound. It has been a canvas for our fears, our hopes, and our stories. We filled it with gods, with monsters, with myths that explained the unexplainable. But as knowledge grew, the silence did not diminish. It deepened. We learned that the stars are not lanterns fixed to a dome, but burning suns across unimaginable distances. We learned that the darkness between them is not empty, but an abyss so vast it defies comprehension. And yet, in all this immensity, one truth remained constant: the silence. No voices, no signals, no other civilizations we can detect. Only quiet, stretching forever. That silence is not simply a fact of the universe, it is the very thing that defines our place in it. And nowhere does that definition feel sharper than when we look toward Proxima Centauri. At only 4.2 light-years away, Proxima should feel close enough to break the silence. It should feel like a neighbour, close enough that if anyone were out there, surely by now we would have heard something, any whisper, any flicker of intelligence. But there is nothing. Radio surveys return only static. Telescopes show only a turbulent star flaring with violence. Even with the promise of a planet orbiting in the habitable zone, the silence continues unbroken. This absence speaks louder than any signal could, reminding us that for all our dreams of cosmic company, the universe so far has given us only ourselves. That realization is both humbling and terrifying. The silence forces us to face questions we would rather avoid. Are we alone? Are the distances so great that civilizations never cross them? Do they collapse before they can reach, or are we surrounded by life that simply chooses not to speak? Each possibility carries weight. If we are alone, then the responsibility is staggering. Everything intelligent in the universe rests on our fragile shoulders. If others exist but are separated by distance and time, then the silence is a reminder of the vastness of the gulf we must cross. And if others are nearby but remain hidden, then perhaps the silence is not absence but warning, a suggestion that speaking too loudly in the dark might invite consequences we cannot imagine. Yet in another sense, the silence is liberating. It forces us to define meaning not by what we find outside ourselves, but by what we create within. If no alien civilizations greet us, if no voices echo back, then it falls to us alone to decide why we exist, what we value, and how far we are willing to go. The silence makes us the authors of our own story, the keepers of our own legacy. And in that, Proxima Centauri takes on an even deeper symbolism, because it is the closest star, the one most likely to answer if anyone were out there. Its silence is not generic, it is personal. It is a star that feels within reach, yet refuses to speak. It is a neighbour who never knocks, never waves, never even acknowledges our presence. That quiet is haunting, but it is also clarifying. It reminds us that even if the universe is teeming with life, the gulf between stars ensures that for now, we stand alone. This aloneness is not weakness. It is a test. The silence is the backdrop against which we must decide who we are. Do we crumble under the weight of isolation, or do we rise to fill the void with our own voices? Do we let the silence convince us that we are insignificant, or do we recognize that it magnifies our significance? Because in a universe that has given us no companions, the act of dreaming, of reaching, of imagining, becomes even more extraordinary. Against the silence, every story we tell, every song we sing, every rocket we launch becomes louder, more defiant, more meaningful. The silence does not diminish us. It frames us. And perhaps that is the real legacy of Proxima's quiet. Not despair, but defiance. The refusal to let the lack of an answer still the questions. The determination to keep sending signals, to keep building telescopes, to keep searching, even when all we find is more silence. The endless waiting becomes part of the story, not a conclusion but a prologue. A constant reminder that what defines us is not what we hear back, but what we choose to send out. Every transmission, every story of Proxima, every dream of reaching it, is a way of filling the silence with ourselves. The silence also sharpens our awareness of Earth, because if we are truly alone, if no one else is out there, then this planet becomes infinitely precious. Every forest, every ocean, every voice becomes more valuable, because they may be the only ones of their kind in all existence. The silence tells us that Earth is not just a home, it may be the only home that intelligence has ever known. That thought can be suffocating, but it can also be empowering. It means that what we do here matters in ways we cannot even comprehend. It means that protecting Earth, cherishing it, nurturing it, is not just about survival. It is about preserving the only spark of consciousness the universe has so far revealed. But the silence also keeps the dream alive, because silence is not proof of absence. It is only proof of distance, of time, of limits we have not yet broken. Proxima Centauri may be quiet, but that does not mean forever. Perhaps one day, centuries from now, our descendants will build instruments capable of hearing what we cannot. Perhaps one day, they will stand on the twilight of Proxima b and discover fossils of life long gone, or microbes clinging to survival, or ruins of civilizations that whispered too faintly for us to hear. The silence is not an ending, it is an invitation. It asks us whether we are willing to keep listening, to keep reaching, to keep hoping, even when the universe offers no encouragement. And so the silence defines us not by what it denies, but by how we respond. We could surrender to it, call it emptiness, let it hollow us out. Or we could embrace it, fill it with our own meaning, let it drive us to shout louder, to dream bigger, to imagine further. That choice is what makes us human. And in that choice, Proxima Centauri becomes more than a star. It becomes the closest embodiment of the silence itself, the first horizon where we test our willingness to keep asking questions with no answers. The silence that defines us is not cruel. It is not kind. It is simply there, vast and indifferent. But within that indifference lies the chance for us to define ourselves, and we have. In our stories, in our science, in our refusal to stop dreaming, we have taken the silence and made it ours. We have turned it into a stage, a backdrop against which our small voices ring louder than they ever could on their own. Proxima Centauri remains silent, but we do not. We fill the void with questions, with dreams, with defiance, and in doing so we ensure that even if the universe never answers, our existence will still matter because we dared to speak into the silence. Time has always been the invisible force that rules our lives, shaping every choice, every dream, every fear. On Earth we measure it in heartbeats, in seasons, in generations. But when we lift our eyes to the stars, time takes on a different character. Merciless, inhuman, stretching across gulfs so vast that even light itself needs years to cross them. Proxima Centauri, sitting at a deceptively modest 4.2 light-years away, forces us to confront the weight of this time more directly than any other star. It is the closest of all neighbours, the one we could almost touch, yet the very act of imagining a journey there collapses under the crushing scale of years. Waiting becomes not just a test of patience, but a revelation of who we are and how fragile our sense of time truly is. Consider what it means for light, the fastest thing in existence, to take over 4 years to bridge the gap. That delay alone is staggering. A message sent today would not even arrive until half a decade has passed, and the reply would not return until a decade later. A simple exchange, "Are you there?" followed by "Yes," would take 10 years. For human beings accustomed to instant communication, to voices and images carried across the globe in milliseconds, such slowness is unbearable. It warps our sense of connection, stretches our relationships until they fray. Now imagine extending that reality not to minutes or years, but to lifetimes. A ship launched toward Proxima at the fastest speeds we have achieved would take tens of thousands of years to arrive. Entire civilizations would rise and fall before it reached its goal. Waiting, in this context, is not measured in generations but in epochs, and that weight is almost too much for the human mind to carry. This is where the dream of Proxima reveals one of its cruelest truths. It forces us to measure our ambitions not against our lifetimes but against time itself. And time, unlike distance or energy, cannot be overcome by engineering alone. Rockets may grow faster, shielding may grow stronger, but time always stretches ahead, indifferent to our urgency. We are creatures of short horizons, wired to respond to seasons and centuries at most. To imagine a journey that lasts tens of thousands of years is to step outside the boundaries of human comprehension. It demands that we think not as individuals, not even as societies, but as species, as links in a chain that extends across unimaginable spans. That kind of thinking is alien to us, but it is precisely what Proxima demands. The weight of time presses most heavily on the concept of generational voyages. The idea of a ship carrying entire societies across centuries or millennia is both practical and terrifying. Practical because it bypasses the limits of individual lifespans. Terrifying because it forces us to surrender the very idea of completion. No one who begins the journey will ever see its end. Every person aboard such a ship is born into a waiting game they did not choose, their lives reduced to maintaining a mission whose fulfillment lies beyond their grasp. Waiting becomes not an act of patience but a destiny, a burden carried by each generation without relief. The psychological toll of such endless waiting is incalculable, and it is here that time becomes not only a physical barrier but a spiritual one. Yet waiting also carries a strange kind of power. Because time is not only an enemy, it is a teacher. It forces us to see beyond the urgency of the present, to stretch our vision across centuries, to imagine futures that will not include us, but will depend on what we do now. Waiting for Proxima, even if it is only in theory, reshapes the way we think about ourselves. It teaches us humility, reminding us that our lifetimes are only flickers in the long arc of the cosmos. It teaches us responsibility, reminding us that what we do now echoes forward, shaping futures we will never see. And it teaches us perseverance, reminding us that some goals are worth striving for even if the reward lies far beyond our reach. The weight of time also exposes the fragile contradiction at the heart of humanity. We are creatures bound to moments, yet we dream in eternities. We crave immediacy, yet we imagine futures that stretch beyond imagination. Proxima Centauri is the perfect symbol of this contradiction. It is close enough to feel possible, yet far enough to demand waiting on a scale that mocks our instincts. It tempts us with the idea of arrival, yet forces us to confront the reality that arrival may not be for us, or even for our children, but for descendants we cannot name. Waiting, in this sense, becomes an act of faith. Not faith in gods or destiny, but faith in ourselves, in the belief that across centuries of silence and struggle, we will not give up. The burden of waiting is not confined to interstellar voyages. It echoes back onto Earth, shaping how we view our own challenges. Climate change, for example, is not a crisis of days or years. It is a crisis of decades and centuries. Solutions demand patience, persistence, and the willingness to sacrifice for futures we will not see. Proxima Centauri mirrors this challenge. It reminds us that waiting is not passivity, but action stretched across time. It is the willingness to endure, to invest, to build for those who come after. In this way, the dream of the stars is not separate from the reality of Earth. It is a reflection of it. Waiting for Proxima becomes a metaphor for waiting for Earth to heal, for humanity to mature, for time itself to bend to our patience. And yet, for all the lessons waiting teaches, it remains a burden. The human mind resists it, chafes against it, rebels at the thought of never arriving. We are not built to sit quietly in the dark for millennia. We are not built to surrender the immediacy of our existence. Waiting stretches us, strains us, tests us in ways we have never been tested. And perhaps that is the final gift of Proxima's distance. It forces us to grow. It forces us to step outside the comfort of lifetimes and learn to think as a species, as participants in a story larger than ourselves. The weight of time is heavy, but it does not crush us. It defines us. It forces us to ask whether we are willing to strive for something that lies beyond our grasp. And in answering yes, even knowing we will never arrive, we declare something profound about ourselves. We declare that meaning is not in reaching the goal, but in the journey itself. We declare that waiting is not emptiness, but fullness. The fullness of hope, of persistence, of belief that tomorrow or the day after or the millennium after, someone will carry the torch forward. Proxima Centauri may never be reached. The waiting may stretch on forever. But the act of waiting, the willingness to endure, is itself the victory. Because in waiting, we prove that we are not bound by the brevity of our lifespans. We prove that we can imagine beyond ourselves. We prove that we are capable of dreaming in the language of the cosmos, where time is measured not in years but in eternities, and that proof is enough. The weight of time may be heavy, but in carrying it, humanity learns what it truly means to live. In the end, the story of Proxima Centauri is not really about a star. It is about us, about who we are, who we want to be, and how far we are willing to stretch our imagination against the limits of the universe. Proxima has sat in the southern sky long before the first human ever looked up, and it will remain long after our species is gone. But during our brief time here, it has become more than a speck of red light. It has become a symbol, a horizon, a challenge, and a mirror. It forces us to confront the vastness of distance, the weight of time, the silence of the cosmos, and the fragility of our own existence. And yet, despite all of this, we still dream of reaching it. That act of dreaming may be the most important thing we have ever done, because it proves that we are more than creatures of survival. We are creatures of wonder. The conclusion is not that we will or will not ever reach Proxima. The conclusion is that the attempt itself, the willingness to imagine beyond possibility, defines us. Every story written about the star, every equation calculated to test the limits of propulsion, every child who looks up and asks, "What's out there?" all of these acts are strands in a thread that stretches across generations. The dream outlives individuals, outlives societies, perhaps even outlives our species, but it remains. And in remaining, it gives us meaning. It reminds us that even in the face of silence, of impossibility, of time itself, we dare to keep going. That daring is not foolishness, it is humanity at its most profound. Proxima Centauri is a paradox. It is both too far and too close, too hostile and too alluring, too silent and yet too loud in the way it speaks through absence. But paradoxes are where meaning lives. We thrive on contradictions because they force us to choose. And faced with Proxima, we have chosen again and again to dream, to imagine a ship where none exists, to write stories of colonists who may never be born, to fill the silence with voices, signals, and questions, even when we know no one may ever answer. That choice says more about us than any arrival ever could. The truth is, we may never need Proxima to save us. Earth, for all its fragility, is still our only true home, and it deserves our care more than any distant star. Yet the dream of Proxima is not wasted, because it reshapes how we see Earth itself. By showing us the hostility of other worlds, it reminds us of the miracle of our own. By showing us the impossibility of escape, it forces us to confront the necessity of stewardship. And by reminding us that horizons are endless, it ensures we never stop striving for more, not because we must flee, but because reaching is what it means to be alive. So the conclusion is simple, though not easy. Proxima Centauri may never welcome us, but it has already changed us. It has already given us a legacy of defiance, of dreaming, of imagining beyond what is allowed. And perhaps that is enough. Because in the end, it is not about arrival. It is about the attempt, the reaching, the refusal to accept silence and distance as the final word. Long after our voices fade, long after our cities are gone, the red ember of Proxima will still burn in the sky, a reminder of the species that once dared to dream of it. And that dream itself, that willingness to imagine against the odds, may be the most enduring thing humanity ever leaves behind.